Good morning, guys. We're going to be looking at rationalizing the denominator today. So far we've dealt with multiplying with our radicals, and now we're going to deal with if I might have a radical in the denominator. Okay. In math, it's kind of a big no-no to have a radical in the denominator, and the way we get rid of this is kind of this process that's called that rationalizing denominator. Essentially, what we're going to do is we're going to multiply the top and the bottom by whatever radical is in the denominator. And the reason we do this is it'll actually cancel a radical out, and we'll end up with a whole number in the denominator instead of a radical, and everything will be okay mathematically. So what this actually looks like here, if I am going to go ahead and multiply on one part of my fraction, kind of like with an equation, I've got to multiply on both, okay, to keep this thing equal, keep it essentially that same value here. So here I'm going to multiply times whatever the radical is in my denominator. So here I would multiply times square root of 2. I'm going to multiply by the exact same thing on the top as well. Okay. The reason why I can do this is because the square root of 2 divided by square root of 2 is just 1, and we can multiply any number times 1 and it doesn't change its value. So that's the reason why I can actually do this. But again, the purpose is to get rid of a radical in the denominator. When I multiply here, on the top, whole numbers times whole numbers, it's 3 times 1 square root of 2. 3 times 1 is 3. I don't have anything else besides the square root of 2, so it's just that square root of 2. So on the top, I just have 3 square root of 2. So there's nothing left for me to do on the top. Okay? On the bottom, in my denominator here, square root of 2 times square root of 2 would get me square root of 4. Okay? This is one where we could do a factor tree, but a lot of these numbers we're able to kind of think of in our head and say, hey, if I do the square root of this number, what is the answer? Square root of 4 is one of those numbers that we should kind of know. Square root of 4 would get me a whole number 2. So again, when we're getting those perfect squares, it should be a whole number answer. So for this one, if you notice, I'd end up with 3 square root of 2 over square root of 4, which is the whole number 2. This would be my final answer. There's nothing left to simplify on the top. The denominator here is a whole number. I can't divide these two or simplify the 3 and the 2, the whole numbers, so I know I am done. Okay? The nice part here is anytime I multiply a radical times itself or times the same radical, and if we're dealing with radicals, I'm talking about square roots, so we're dealing with index of 2 here. Okay? So square root times the square root. So if I said square root of 4 times the square root of 4, my answer is just going to get me 4. Okay? The reason, square root of 16, 4 times 4 is 16. Square root of 16 is just 4, so I get my whole number 4. It's nice because that works every time you multiply a square root times itself, it will get you that whole number answer, which is why we're choosing to multiply times whatever the radical is in the denominator. Okay? Our second example over here. Now I have a radical on top and bottom. Okay? There are a couple different ways to do this, and some teachers may show you a different method. Personally, I'm just going to show you guys the rationalized denominator, and then we'll kind of go from there. If you have questions or you're concerned about it, we can always kind of talk about a different method, but this is one method that should work. Okay? So if the denominator here has a radical, again, I'm going to multiply times whatever that radical might be. So here I'm going to multiply times square root of 12. Okay? Again, whatever the radical is in the denominator, that's what I'm multiplying times. In the denominator, square root of 12 times square root of 12 gives me 12. So I know I have a 12 in the denominator. On the top, I've got square root of 6 times square root of 12. So 6 times 12 should get me 72. And it's a radical. Okay? Again, those don't disappear. Like the radical doesn't disappear here because it's not the same number times the same number. Okay? So here, I'm going to have to do my factor tree to simplify my 72. So up on top, I'm going to do this up here. I could have 72 and split this thing up. So we just used 12 and 6, so I might as well just use 12 and 6 here. 12 splits to 6 and 2, 3 and 2. 6 breaks to 2 and 3. So here I have a pair of 2's, and I have a really far apart pair of 3's. So it brings out a whole number 2, a whole number 3, and my leftover 2 goes inside my radical. Okay, so 2 times 3 is 6. So on top, I would have 6 square root of 2 all over 12. Okay, so again, this is just that process of simplifying our radical that we've been working on. Again, that's the purpose of us doing that first. So I simplified that radical on top down to 6 square root of 2. Now I just double check with my whole numbers. Can I actually simplify it further? So here's 6 and 12. I can divide both 6 and 12 by 6. Or if you think 6 over 12 is the same thing as 1/2. So I would say 6 divided by 6 is just 1. So I'd have 1 square root of 2 on top. And then 12 divided by 6 is 2. So my answer is going to be square root of 2 over 2. Okay? Again, this is called rationalizing the denominator. The goal, like I said, is to have no radicals in the denominator at the end. I'm going to show you one last one, a third one here, briefly, and then we'll let you guys kind of give this a shot yourself. So number 3 here, real quick. If I had, let's say, let's go 4 square root of 2 over 3 square root of 3. Okay? So now what happens when I have numbers in front of these? Same process, okay? There's nothing really changing with what we're actually doing. We just might have one extra step with when we multiply, okay? So again, I'm going to look at my denominator and be like, hey, Mr. Schultz got a radical in the denominator, so to get rid of it, I multiply it by whatever that radical is. So here I'm going to multiply times the square root of 3, because that is what I have in the denominator, okay? I don't have to multiply times 3 square root of 3, just square root of 3. Because I multiply the bottom, I got to multiply the top. So again, here I'm only able to multiply radical times radical and whole number times whole number. So technically there is a whole number 1 in front of this. So I could say 4 times 1 gets me 4. Square root of 2 times square root of 3 gets me square root of 6. In the denominator, I'd have 3 times 1, which is 3. Square root of 3 times square root of 3. And again, anytime I multiply the same number times itself as a radical, it just gets me that whole number out. So here I would have square root of 3 times square root of 3 gets me 3. Notice it's just being multiplied. 3 times square root of 3 looks just like this, really when they're next to each other being multiplied, so that's the reason why I have 3 times 3 there. To finish this off, the top part, there's nothing really left for me to do. If I do the square root of 6 and split it in a factor tree, it'd be 2 and 3, and those don't go any further, so it just stays that square root of 6. So on top I have 4 square root of 6. In the denominator I have 3 times 3, which gets me 9. The 4 and the 9 I can't have or don't have anything that I can divide by both, so these are going to stay the same. The tempting thing to do, and what some of you might want to look at, and I will tell you please don't, is if it's in a radical, so this 6 is inside the radical, and this 9, I understand both of those can be divided by 3, but because one's in the radical and one is not, we can't simplify that and divide both by 3. Okay, so this would be done as is. The 4 and the 9 can't simplify, so I would be done with no radical in the denominator. That's the biggest thing here is our goal is to have no radical in the denominator at the end. Again, this is called rationalizing denominators. Okay. Again, if you've got any questions, let me or Mr. Connor know. Otherwise, I will see you guys soon.